In this question, there's a tire that is being pulled by 3 people. So this is looking at bird's eye view. So we have Alex, Betty, and Charles pulling this tire in 3 different directions. And the question says that the tire remains stationary, which means the acceleration is 0 in both x and y directions. So Alex pulls with the force F of A. So right here will be FA, and then FB for Betty, and then FC for Charles. And they're not giving us the value of FC. They're asking what is the magnitude of Betty's force FB. So let's look at some angles here. So if we were to look at this in x and y directions, let's look at the coordinate system right here. And you can see that this right here is 90 degrees, which means right here is going to be 137. So this is going to be 137 minus 90, which is 47 degrees. And we don't know the direction of Charles's force here. Let's call it theta. So let's draw a force chart. So we have 3 forces, x and y. Here we are only looking at the xy plane here because this is bird's eye view. We are not considering the weight or a normal force, which will be in the z direction. So only x and y. So we are looking at in a 2D perspective. So we have 3 forces. We have FA, FB, and FC. So FA is in the second quadrant, so we have a negative x component. We have negative F sub A cosine of 47 degrees. In the y direction, we have positive F sub A sine of 47. FB is in the y direction or negative y direction, so there's no x component. We have a negative y direction. And then for FC, it is in the first quadrant, so both x and y components are positive. So we'll have positive FC cosine theta. We don't know the value of theta. And then positive FC sine of theta for y component. So the next up, we are going to add summation of forces in the x and y direction. So in the y, we just add up the column, so that is negative FA cosine 47 plus FC cosine of theta. In the y direction, we have FA sine of 47 minus FB plus FC sine of theta. Now this is in both x and y directions being pulled. Let's look at Newton's second law in the x direction. We have summation of Fx equals max. So what we have for f sub x is this part here. So we have negative Fa cosine of 47 plus Fc cosine of theta, and that is equal to mass times acceleration in the x direction. And as you know that this is stationary, because that's what the question is telling us, which means our ax is 0, which means this is 0. So then what we have is negative Fa cosine of 47 plus Fc cosine of theta is equal to 0. So for FA, we can plug in our value of 220 newtons, which is given right here. So we have FC, which is 170 newtons. Cosine of theta equal to 220 cosine of 47, and that gives us cosine theta, which is 220 cosine 47 divided by 170, and then you take the inverse cosine of that, and that gives us theta equals 28 degrees. So now that we know the angle of FC, let's go and look at F sub y, because the question is asking about the magnitude of FB. So this is MAY. So now we are going to look at the y component here. So FA is 170 sine of 47 minus FB, which is what we need to find, plus FC is 170 sine of theta, and we found theta as to be 28, and that is equal to M times AY, and AY here is again 0 because this is a stationary situation, so this entire thing is equal to 0, and you can find FB from this equation, and that is 240 newtons.